The Sun, our star that sits at the center of our solar system, a nearly perfect sphere of hot plasma heated to incandescence by nuclear fusion reactions in its core. It sends its energy to the Earth and across the solar system. The Sun is our most important energy source for life. It drives our ecosystem, and its energy feeds every organism. Variations in its energy push diversity and makes the world as we know it. And yet, it is the one thing that could destroy us all and leave planet Earth a desert wasteland. It bombards our planet with enough nuclear radiation to kill every single living thing. The only thing stopping this is the Earth acting like a giant magnet. When charged alpha and beta particles interact with a magnetic field, something very special happens, and it is just as well this is the case. Let's shine some light on magnetic fields. This is Think 4. In physics, a field is an area where something will experience a force. In a gravitational field, a mass will experience a force. In an electric field, any charged particle will experience a force. And most importantly for us, in a magnetic field, a moving electric charge will experience a force. And I can prove it. In a cathode ray tube, a beam of electrons is generated and fired across the apparatus so we can see it. The rings around the screen are coils which we can use to create a magnetic field. When the magnetic field is present, this happens. The beam of electrons is deflected off its original path. This is what protects us from all the nasty radiation from the sun. You need to know how to figure out three things: the direction of the force acting on the particle, the direction the magnetic field is acting, and the direction of flow of the electric current. Interestingly, these things all act perpendicular to one another, like this. To understand in which direction these three quantities are acting, we need to use the right-hand rule. To start, you give a good thumbs up. Your thumb now represents the direction of the force acting on the particle, and therefore the direction that it will move when inside the magnetic field. Next, point your first finger forwards. This is the direction of the magnetic field. Finally, point your middle finger away from your palm. This is the direction of the magnetic current. Let's test it. If we go back to our cathode ray tube, the direction of the current is this. The force acting on the electrons is clearly pushing it up, so our thumb pointing up is correct. That means our first finger should be pointing into the page and the magnetic field must be acting that way. How do we show that something is moving into or out of the page? This will almost always be the magnetic field when you're working on this, and we have a pretty easy way of showing it. If we imagine the arrow is traveling into the page, we see a cross, which is the back of the arrow. If it's coming out of the page, we see the tip of the arrow, which would just be a dot. So if we draw an electron moving into a field like this, we can use the right-hand rule to determine it will travel downwards and will eventually travel in a circle. The sun drives everything on planet Earth, from the food we eat to the ecosystems we are part of. Our amazing planet is the way it is because we live close enough to a very dangerous source of nuclear radiation, but are fortunate enough to have a very convenient magnetic field that shelters us from complete obliteration. Earth's magnetism is a very attractive force indeed, and vital to life as we know it. That's good to know. This was Think 4. Thanks for watching.